Okay, we're now going to talk about sets. Okay, so we're going to go through what do these symbols represent? Which sets do they represent? Okay, and when we talk about sets, I mean sets of numbers. Okay, we do use some special symbols to represent certain groups of numbers. So this first one is the real numbers. Okay, and a real number is any number you would have encountered up to GCSE level. Okay, if you've done A-level further maths, you would have encountered numbers involving I, okay, which are not real numbers, but all other numbers are real numbers. Okay, so any number you can think of, surds, fractions, integers, and so on, they're all called real numbers. And symbol, in terms of how we actually write this symbol when using a pen, you'd write it like this, okay, because the way it's typed there is a little bit complicated. Okay, Z is the set of integers. Okay, so to represent sets, we often use curly brackets. So in my curly brackets, if I was listing out all the integers, we got 0, we got 1, 2, 3, going off infinitely that way. Okay, and then we've got -1, -2, so on going off infinitely that way. Okay, so any whole number is an integer, and how we write this symbol out is like this. Okay, so Q is your rational numbers. So rational numbers are numbers that can be written as fractions, where A and B are integers. Okay, however, B cannot be equal to 0 because we cannot have 0 in the denominator of a fraction. Okay, so for example, like 2/3 is a rational number. An integer is also a rational number because like 5 can be written as 5/1. Okay, numbers that are irrational. Okay, so irrational numbers are the ones that wouldn't be in this set. So irrational numbers include, think about one of the most famous numbers that you know, would be pi, and then surds. So for example, √2. Now an irrational number as a decimal will go on forever, but in no specific pattern. Okay, so they're non-recurring and non-terminating decimals. Okay, whereas rational numbers would include the recurring decimals and the terminating ones. Okay, N is your, oh, I did forget how you'd actually write the symbol for the rational numbers. Okay, you would write a Q and then put a line for it like that. Okay. Now, N is the natural numbers. The natural numbers are mainly defined as the positive integers. Now, some people do include 0, okay, but we won't be. Okay, so the natural numbers N are the positive integers, and the symbol we would write out is this. Okay, next is C, which is our complex numbers. Now, all the sets I've talked about so far prior to this were all real numbers, so all of these are contained within the real numbers, would say they're a subset of the real numbers. The complex numbers is the first set that actually includes numbers outside the real numbers, because it would include any numbers with I in it. However, all the real numbers are complex. Okay, so the number 5 is a complex number, but in addition, we have these numbers involving I. And how we write this symbol is a C like this. All right, the next 4 sets on here are related to the integers, but it's more about the notation, which might pop up in questions that you do. This set here is the integers without 0. Okay, because sometimes you want to include 0 like in the denominator of a fraction. But next set here is actually the same thing, it's just different notation. Okay, with /. Then we've got a Z with a plus. This is just another way of writing the positive integers. So this is actually the same as the natural numbers. And then this bottom one here is the positive integers again. However, 0 is now included. because 0 is neither positive nor negative. And you can probably think about other ways that we could potentially write some of the other sets using these other little bits of notation. Now for other sets, the curly bracket notation is used either with a list or an explanation. So for example, I'll write a set out here. Okay, here's a set where I've listed out all the values in the set. So the values in the set are called elements. So we'd say that 0 is an element, 2 is an element, 4 is an element, and so on. We separate them with commas. And this here would be an example of a finite set, because there is a finite number of elements. There's only 5 of them, whereas all of these ones are infinite sets, okay, because they go on forever. Okay, the integers, you can keep adding 1 and so on. Now, some infinite sets will be written with curly brackets. So it talks about an explanation. So for example, we could write x such that x is a real number. Okay, so this notation here means is an element of. So this is saying x such that x is an element of the real numbers, and then would write our explanation of what specific x value we want. So we might write the following. Okay, so we're saying that x is a real number and x is between 1 and 2. So it's essentially any number you can think of between 1 and 2, including 1 and 2. Okay, so like 1.23, 1.278. Okay, so you can keep going to that extra decimal place. That's why we would use this notation to summarize all the values in this set. Okay, and that would also be an infinite set technically, although it's infinite in a slightly different way to the ones above because it is bounded between the 1 and the 2.